permanently, and also in 1, 2, 3 cases, basically there is a higher current rating that is also changing in this case. So then we go for the next. Here, as I told you, basically I'm going to tell you more about these 3, 5, 10, and 16, the lower ranges and IP. But before that, basically we should also look at the wave shape of this, and also look at some other parameters of lightning, for example, the specific energy and all. So the impulse current is 200 kiloamperes in level 1, you know it. Level 2 is 150, level 3 is 100, and specific energy can be in 10 megajoules per ohm, and it can reduce down to 2.5 megajoules per ohm. And what your equipment can withstand, just see a computer or so, it can't take even 400, 500 joules of energy also, basically, during lightning. So small MOV is there, basically, which is there to discharge this small lightning of joules, 400, 500, let us say 1 kilojoule. Here we're talking about one, uh, 10 times more, 10 lakh time more than that. This is the megajoules we are talking about here. So idea is to reduce this energy from megajoules, which is offered by lightning, to some joules which can go inside the equipment safely. We cannot nullify it, but we have to reduce it to a safe level, actually. Yeah. And the huge charge is also included, like in the welding case, there's a huge charge there which can create a puncture, and of course lightning can also create a puncture in the tin sheds and all this. Yeah, is possible. And the time parameter is 10 by 350, which I'm going to explain in the next slide here. If you see here, I've just taken a peak current of 100 kiloampere. Lightning strikes, and lightning basically will rise from approximately 10% to 100% of its peak value. You see, lightning is a kind of pulse. First thing is to be seen like this. It's a kind of pulse. It's not a sine wave or something like this. It's a kind of pulse. And once it's like, if you're throwing stone in the fixed or basically still water, there will be waves. So accordingly, basically lightning when strike, it also creates waves. There will be one primary or first stroke, and then there will be some secondary strokes. Basically, it looks like basically a kind of waves which are generated in the pond, a still pond, by throwing the stone. So here you see the green portion of this, which is showing the actually wave. It takes around 10 microseconds to reach to the top level. It's actually, in the very engineering term, it's from 10% to 90%. But just for understanding, you can take that it rises in 10 microseconds, and it comes to half value, which is shown at the half of the figure, 50 kiloampere in 350 microseconds actually. So when we are showing this, that means basically we can draw the full curve. If the peak current is given to us, if the wave shape microseconds is given to us, we can draw the full curve. On the y-axis, you can see the current in kiloamperes, and x-axis, you can see the time in microseconds. Yeah. So within microsecond, 10 microseconds reaches to kiloamperes, and then comes down to 0 in few microseconds only. Let's say 1 millisecond max. So here you see that the rate of change of this current di by dt is very, very, very high actually in this case. And of course, with this kind of rate of change di by dt, even if it is flowing from small cables, actually it will create a voltage L di by dt. So these voltages which are created due to this kind of effect of the wave shapes, actually these are also very dangerous for the equipment, because it can be in volts or maybe sometime in kilovolts actually, apart from the direct effect when when this lightning actually flows through the ground. So one is 10 by 350. Another thing that is shown here in the red color is 8 by 20 wave, which shows the current is quite less here, 5, 6, 10 kiloampere maximum. Actually, it can go up to 20 kiloampere maximum in this case. And here you will see that lightning rises, or this surge, which is a red color wave shape here, it rises in approximately 8 microsecond and comes back to half value in 20 microsecond. So 8 by 20 and 10 by 350. 10 by 350, whenever we are saying 10 by 350, that means we are talking about lightning. Simple. When we are talking about 8 by 20, then we are talking about a small surge. And you can see the difference between the two wave shapes. The green curve is quite big curve, area wise also. In general terms, it looks bigger. So area of this curve will be integral of I square into t, y-axis in square into x-axis. Y-axis is I, means I square t. And I square T is nothing but energy. So, bigger wave, that means bigger area wave shows the bigger energy, and that is what we can see in the table also there. Green column and red column, basically, you can see that there is a difference in the specific energy also there. So, the difference between 1 and 2 is lightning and surge. Lightning is 10 by 350, surge is 8 by 20, and it is also known as class 1 and class 2, type 1 and type 2. Earlier, the arresters used for lightning protection were known as class B arresters, that means class 1 arresters, and the arresters used for 8 by 20 wave, they are known as type 2 arrestor or class B arresters actually. So that is also one change that you must see. And that is a differentiation between lightning and surge here. I think it's quite clear. So when lightning strikes, it is like a wave, and as I told you, when it strikes, then definitely it is going to create a kind of effect, and this effect will be induced effect or the direct effect, and you can see this effect in approximately 2 kilometer radius. That is quite possible that within 2 kilometer radius you will see the effect of this. Now, second thing is, so here what is important to be seen is that lightning need not strike directly on the facility which are owned by you. Even if lightning is striking somewhere at a distance, it can still show its effect to to your facilities. Shashankji, I can't change the slides somehow. Yeah. Now, somebody has taken the control of this somehow. It looks like. I'll share again. Oh, so pity. Okay, so we were here, and we could see the effect. Sorry for this disturbance, which somehow diluted the suspense also. But anyway, I know it is still going to be interesting. So let us go forward. Forgiving the technology for some time. So here you can see this. This is one animal which was shown, and if the lightning strikes on the tree here, there will be huge potential rise in the tree, which will decay with the surface also, with the distance also. From a remote point, this potential will be 500 kV, but as you go further, this potential will keep on decaying, and there is a chance that basically such kind of scenario can happen where a person or a animal with wide legs here basically it can be exposed to two different very hazardous and very dangerous potentials ranging in kilovolts, and can cause very heavy current to flow through the body. Yesterday Mr. Arora told very nicely about what is the susceptible or expected body current actually, and it will definitely exceed the limit because we are exposing the body to kilovolts here, and definitely basically this will create a huge current to flow through the body, and then it can cause definitely injury or maybe fatality. But at the same time, that is the reason that in case of a drop of the high voltage cable, or in case of lightning, basically it is advised to keep your feet together, take frog like jumps, and not basically not walk with the wide legs, or not run basically during this time, because it can create momentarily very high potential difference, which can cause very high currents for that moment, creating shock, and also very, very dangerous for the life actually. I'm not talking the word using the word health here, for the life. Yeah. So also basically yesterday Mr. Arora told very clearly that how Earth's bits they should be connected together or not. So he mentioned it very clearly. These are to be same. There is no different Earth. Different Earth could be somewhere else in the planet basically, but we have one Earth only, and at one side we have to maintain one Earth only. Actually, this is the demand and this is the requirement from uh, any kind of protection hazard. I would say basically lightning or high voltage, whatever basically, unless it is regulated by some clauses in a particular safety guidelines or so. Basically, it is always recommended to have one earth. One earth doesn't mean one pit. It can be different pits connected together actually, so that this difference of the potential can be minimized. And secondly, the ground loops actually which are created by difference potential, they should be minimized, creating more safety, and also basically it helps in uh, step potential, touch potential reduction too. So now just a effect of lightning is shown here basically in this slide too. If you look at this slide, lightning can strike on the building. Of course, that can be one effect, would be the worst one. Second could be a lightning striking on the lines actually. Lightning can strike uh, within the clouds, cloud to cloud lightning, and can create very huge electromagnetic field affecting the lines, and this effect or surges can travel to the building. Of course, via the transformer, there will be some reduction via the earth of the transformer, but at the same time, we have to see the capacitive coupling between the primary and secondary, and this high frequency thing can travel from primary to secondary very easily. And also, if there is a possibility of lightning, or if the lightning strikes close to the building, there would be effect seen in the building itself. As we have already seen, it's an electromagnetic effect. You can't just nullify it, actually. Then comes the standards, actually. When we talk about standards, so IEC is the main standard, which is followed with all the commas, full stops, I would say errors, in the same way by BIS actually, because we are a IEC country, and we have to always go for all kind of systems which are accepted by IEC, not by any other system. So IEC accepts Franklin rod system and the mesh system actually for capturing the lightning. And also the down conducting principle is also very clearly mentioned, that it has to work on a principle of Faraday cage, that your whole building should look like a Faraday cage, like you're traveling in an aeroplane or so. If lightning strikes on the aeroplane, nothing happens because you are in a cage kind of structure. Inside that the electric field is still zero because you are covered with metal. Yeah. So of course, these all aspects basically are carried out in a very simple way in IEC. One has to really read through it. And yesterday Nihar was also telling that, okay, go through the manuals, go through the books, where these are very, very important. And once you go through that, you find out very good surprises also. And then you dig out the reasons of this, and then you basically gain the expertise. So here 62305 is the standard, which is a compilation of 61312 standards, 61024 standards, which were published before this IEC 62305 was published in 2006 in the world market, and in India it was adopted in 2015. 2016 we came up with our national building code, which refers to IEC 62305 only. New safety guidelines of CEA are also talking about only IEC 62305 standards. These are actually really, very well written standards about lighting protection, and they are the Bibles of lighting protection actually. Yeah, but there are many other standards which are driven from these standards, like 61643 and 60364. Many standards are there, and they are having different parts also later on. So it's like, once you go into the ocean, there is always a limitless opportunities available for all. Yeah. So 62305 part 1 tells you about the general principles, like whatever I've shown you, the wave shapes, the effects of lightning in terms of its electrical effect, thermal effects, mechanical effects. All these things are shown in 62305 part 1. Then part 2 is all about risk analysis. If the lightning strikes in any building, then what is the risk associated with this building, kind of economic loss, human life loss or heritage loss or service loss, all these losses are considered. What is the risk there? It is calculated. What is the acceptable risk that is to be known to the user of that building or provider of the service from that building? And if the risk exposed by the lightning in the given condition of the building is more than what one can accept, then you have to go for some measures. Some measures can be lightning protection or surge protection. So lightning protection is defined in 62305 part 3. So it tells you about the protection of the structures, building, right, against the lightning, how to capture the lightning, how to down conduct the lightning, how to do the earth termination. It is not a earthing standard. Please try to understand. It is lightning protection standard. So when you have to catch the lightning, how to catch it. Second is how to down conduct it, how to minimize the electric field effect inside the building, how to connect it efficiently to the earthing system. Mr. Arora yesterday told very clearly about the earthing system. Of course, can be elaborated further, of course, and you have to appreciate that it was again with him 2 hours only, less than 2 hours rather. And then basically, comes inside the building. Inside the building, of course, protection of the human beings is one part, and second is the equipment. Yeah, nobody wants to live without telecom, nobody wants to live without TV, but when we talk about industries, there are machines, important machines. Nobody wants any kind of variation in the output of the machines, basically, due to any fluctuation in the power. So people want, even if the lightning strikes, my power should be stable, smooth, without any interruption. Actually, the machine should not get damaged, the card should not get damaged. In case of control system, nobody wants that due to lightning, basically the control system, like you have relay control systems and things like that, they should get damaged. Nobody wants that, even in the substation and all. Shashangi, automatically this is going to unsharing. I don't know why. I'm again sharing. But every time we have to pass through this total. Okay. Yeah, the slides are visible. If anybody can just say on the chat. Are slides visible, sir? Anybody? Just on the chat if somebody can confirm. Okay, thanks. Thanks, Gauravji. Thanks everyone. Thanks Adwalji. Thanks Shwanji. We'll carry on now. Yes, slides are visible and it's nicely visible. Hopefully, we don't get this slide non-sharing mode again. I don't know how it is happening, but somehow it is happening. Yeah. Okay. So we know about the standards now. We talk about the pillar of the lightning protection. What is the basic thing about lightning protection? Only one key. That is the equal potential bonding. Every potential of all metal parts, be it conductive, non-conductive, they should be at the same potential. If everything is at the same potential, there is no potential difference. If there is no potential difference, there is no net current flowing between the two. We can protect human being, we can protect all the equipment, we can protect our services, we can protect fire, any kind of hazards also. No potential means presentation is not visible. Mr. Kunal Darji is saying, but others are saying the slides are visible. Is it not visible? For others, actually, Gauravji, can you tell, Shwanji? It is visible. So, Mr. Darji, I think you have to reconnect again, actually, because everybody else can see this. Yeah. Okay. So please now. Yeah. So here I was mentioning about the lightning equipotential bonding. For sure, basically, let's see basically what happens the when the lightning strikes. This is a building which is protected by lightning, and when the lightning strikes on this building, yeah, lightning will try to go to the ground. But on the way to the ground, basically, it can find other conductors also, which can get associated. That means lightning can get associated with those conductors, and it can start flowing in those direction also. It is not that it will always carry the shortest path. Definitely it carry the shortest path, but for maximum current. But some part of the current can go, here and there, and it can definitely create some kind of damages in the process part also. So this is one, let's say, and this kind of current, if is flowing in the hazardous area, for example, in the process industry, then what happens basically? Of course, there could be a damage, and if damage happens uh, to a controlling valve or something like that, it can lead to subsequent further bigger damages also. If there is an arc, then of course you can imagine that a hydrocarbon and they're close to the arc there, what is going to happen there. So it can have the subsequent effects which can be much more dangerous actually. So if the lightning strike here on this structure, not on the building, then of course, then again, basically it will have some partial currents flowing on the control cables, and it can go to your control room, and of course in control room also there could be damages. So it is not that all lightning will go to the earth from the shortest part. It is also imaged basically. Some part definitely is routed through the other conductor, which are, it's a kind of resistance divider actually. It's a current and resistance divider. More resistance, less current. Less resistance, more current. But some current is there in all resistance actually. And this, in case of lightning, this some current is also very dangerous actually. So here, in case of lightning, then what our National Building Code says, that is to be understood here. First, to do the risk assessment. If the lightning strike, what happens? Then design a proper lightning protection system by professionals and all. Then do not use the method which are not allowed by us actually. That is also mentioned in the National Building Code, and use the surge protection devices to the critical equipment to protect the critical equipment. Yeah. So this is very simply the case, and I'm sure that basically this is well understood and clear. So how to calculate the risk? Very small way I have given this. Lightning protection concept is implemented in non-isolated and isolated. Non-isolated means bonded way. In India, we are bonding all the metal part together. Everybody knows that. That means the potential of each and every metal will be same. But there is a method also where you can isolate the lightning carrying parts from the other metal parts, so that there is no effect of lightning on these panels or these special equipment. Like for example, data center, nobody will like any lightning current. Even iota of lightning current should flow close to the this server racks. They will like to keep it away. Even the cables which are entering into the server rack should not go close to the lightning carrying conductors. So then you will go with the separation distance kind of thing there actually, right? So there could be mix also, and there could be one system also. And then protection of the equipment. So here basically you have to see direct hazards, as I told you, sparking, heating, and there could be uncontrolled flashover, which is there normally in the high-rise buildings or towers basically. So these are all very dangerous things which, if happen, can create havoc actually. So first is to calculate the risk. First you see the source of the risk. Source is the lightning, and lightning can strike on the building, close to the building, on the lines, close to the lines. Very simple. On the building, close to the building, on the line, close to the line. All these are sources. Through this, basically, your equipment in the building will carry the lightning current. Yeah, can't avoid it. This is natural, really can't avoid it. Then risk is risk of loss of human life. If there is a loss or probability of loss of 1 out of 1 lakh, that means 10 raised to power minus 5, 1 out of 1 lakh, then also you have to go for proper lightning protection system, because human life is most important actually. So we cannot just say that, okay, chalta hai. This will not go here. 1 out of 1 lakh. Look at the possibilities, probabilities. Even if we are having such a low possibility of loss of human life, we have to go for lighting protection system as per the standards actually. Yeah. And we don't want to say the standards here. It's a responsibility here, that, no life should be lost because of lightning. And don't get, to these figures of approximately 3,000 numbers per year because of lightning recorded. Unrecorded are many. Everybody knows that, how many people died in Bihar 3 months back due to lightning. 103 numbers in one day, one single day actually. Yeah, it's it's quite big actually, and very unfortunate also. So risk of loss of services to public, for example, telecom services, a water service. For example, you are having clean water coming from this water treatment plants, and water treatment plants is affected by lightning. What kind of water will you get? Security, all these things are services. Whatever is the cost of the camera, that is not important, but the kind of service this camera is providing is very important. Yeah. So of course nobody will like any kind of miss in the surveillance and all. So of course we will like the services to be on 24/7. So these are the risks, we have to calculate how important the services are. Suppose there is a lightning strike on the Qutub Minar now. Qutub Minar is only one in the world actually. If it is gone, it's gone. Then simply, loss of the culture heritage. Nobody will like to have it. So lighting protection is required. Then risk of the loss of economic value for the industries and all. There is of course, the lightning strike, it can hamper the whole production unit. For example, automobile unit, everything automated actually, sheet cutting and all these things. Lightning strikes, then sheet cutting machine is doing some wrong cutting there, loss of material, or totally stopped, production totally stopped. Was actually loss of economic value. Yeah. So of course these are the points actually which are to be calculated, and the methods for calculations are given in IEC standards, or National Building Code also, and also basically other standards that we have. We should definitely go for that. And for calculating the risk, there are many factors. For example, you are having a building in Delhi or a place like Bombay. So lighting flash density of these two areas are different. Since the lighting flash density is different, Kerala, for example, lighting flash density is totally different, much higher lighting flash density. And if building is surrounded by other structures, high rise, for example, towers, metallic towers, or things like that, or it's the isolated building, top of a hill, for example, then what happens there? You can see yourself as a general common sense will say that, if lightning will strike on this area, which is quite populated area, the probability of striking one is less and other is more, kind of thing. But if it is isolated building on the roof of the hill, basically, of course, the strike possibility will be much higher. So secondly, the area, the dimension of the building is also deciding factor. More is the area, more is the possibility of strike. Either nahi hoga to udhar ho jayega, basically, kind of thing. Location factor, as I just explained. Installation factor of the power supply. How the power supply coming inside, underground, or it is basically overhead, and how the data lines are there, because these are all the sources of lightning. Then the environmental factor, for example, coastal area, minerals, actually, that like why lightning is happening too much in Bihar and all this area. I think more because of the minerals in the soil there, actually. So equipment withstand level, that is also very important. If the lightning strikes, then what is the level of the energy the equipment can withstand? If it is more than that, then of course you have to go for some protection. Type of soil, as Mr. Arora also explained yesterday, different types of soils. These are there is a connection between the two, earthing and lightning. But what is a good earthing? Basically, that is something which nobody can define, because good for me is different, for you may be different, for a person sitting in America is different. But we have to just see that what is the common requirement here, as Mr. Arora yesterday told. And fire risk, of course, there is a possibility of fire, let's say starch factory, and there is a possibility of fire there due to lightning. Then what will you do? What happened in BPCL tanks? I think 2017. One of the tank got fire because of lightning in Butcher Island, close to Mumbai, actually. And the uh, fire could not be extinguished even for 4 days, actually. What would happen if that tank was there in the middle of the city, actually? Just imagine. So it can create much bigger risk than we think. And factors for touch voltage, step voltage also exist for this, because they're source of very high current in kiloamperes, and current when flows through the resistance, whatever earth resistance you have, it will create GPR and surface potential, and then also basically it can create problems. So there are factors, and these factors basically you have to see and calculate the risk. There is a method, detailed method of calculating the risk. And if you go for just risk calculation only, it will take a half day actually just to understand the subject of risk calculation. There are softwares also available now. Yeah. And for example, lightning strikes on a railway station, and there is a panic because of this. What will happen? So there are many factors which are taken into that. Considering how many people will be there in a particular premises when the lightning strikes, and unmanned sites is a different risk, manned sites is a different risk, and of course one has to calculate based on all these factors. So you have to see that whether you have done the lightning risk analysis of your facilities as per IC or not. If not, then get it done. Actually, simply there is no alternative to it. So first we have done with the risk kind of thing, that we have to calculate the risk, and if the risk is more than what we can accept, then we have to go for lighting protection system. Now we will talk about lighting protection systems. Actually, so far we were talking about general principles of lighting, general introduction of lighting parameters. We were talking about general risks, national building codes, IEC standards, and everything. Now how to protect kind of thing. This is what, in short, I'm going to tell you today. So in this, there are three parts, as I told you. First is to capture the lighting, second is to down conduct the lighting, and third is to dissipate the lighting into the earth. So when we talk about capturing of the light, so the question that comes into my mind is, one is, how many termination rods are required? What should be the location of the rods? What should be the height of the rods? ESC terminals, yes or no? Side flashes. Now you know about side flashes. You will say that yes, it is required. So yeah, we'll try to cover these chapters here now. So let me show you one diagram actually. This is first of all, basically, before going to the diagram, and let me work this. See, there are three methods which are actually given in IC for the capturing of lightning. Air termination system doesn't mean always is rod. It can be a mesh also. It can be rod. So mesh or rod, too. Now mesh can protect you with some angle of protection that everybody knows, and in India we know that it's a 45 degree, but that is also another myth that we have. The angle of protection depends upon height of the rod from the object that we want to protect, actually. So if we are talking about this rod, there would be some angle, but this angle will vary based on the height. So where these rods are to be installed, of course, there is one is the angle method, but the angle value of the angle you have to choose as per the height, and based on that you can select the number of rods. And the other method is the rolling sphere method. Rolling sphere method is nothing but is just imagining a ball. A ball is a sphere. Roll it over your structure. Wherever this touches, this ball touches, that is the possible point of strike of lightning, and that is where you need the rod. Now, what should be the radius of this rod? This is what is dependent on the current. Now you know that is the lower current or higher current. Is the lower current actually, because it is difficult to catch the lower current, and the minimum radius is 20 meter. 20 meter means for 3 kiloampere, and 3 kiloampere to 200 kiloampere was for level 1 protection. So that means basically when we're talking about level 1 protection, we have to go for 20 meter radius. How this 20 meter is calculated, I'll tell you that also actually. But here in the table you can see that classes of protection, class 1, 2, 3, 4. Radius of rolling sphere is this. And other method that you can do is you can create a mesh. Sometimes basically, there is a parking space now on the different floors. How can you put rods there? There are, some visible issues like elegance issues and all these things. So of course, in that case, you can put the mesh there. Yeah. So mesh is the method, rod is the method. The two methods of catching the lightning in general. And for mesh also, the size of the mesh will also vary based on the level of the lighting protection system or level LPL. So here 5 by 5 meter, for example, is the cross section area of the mesh for level 1, which is 3 to 200 kiloampere, and for level 4 it is 20 by 20. That is a wider mesh basically here. So less metal will be used, and if you see cost wise also, level 4 protection will be less. But level 4 is sufficient or not, that will be decided by the risk analysis. What level of protection do you need? 4, 3, 2 or 1? Yeah. So that will be decided and calculated by the risk. How much risk you have if you do not have any protection. If you go for, let us say, level 4 protection, whether you are coming in the safe zone or not. If not, then go for 3, 2 and 1. Yeah. So rolling sphere method, just for people, who are, just to make it simple, basically this is a house and these are some points where it will be touching, and wherever it touches, basically these are the possible point of strike of lightning, and that is where you have to put the rods. And this sphere will have different radiuses based on the level. Like for level 4, it is 60 meter, bigger one, it will touch at less places. A smaller one will touch at many places actually. So 45 meter is the radius for level 3, 30 meter level 2 and 20 meter level 1. So if you put the rod, the sphere will touch on the rods, not on the surface. Lightning will strike on the rod, not on the surface of the building. So that is the main concept of this. So now, sometimes the question comes whether you can use the ESC terminals or no. These are not allowed by IEC actually. They say that every rod acts like a normal rod only. Actually, it's not that any specific. So they have not defined any such technologies which are not proven actually. So here it is mentioned that all types of air termination systems shall be positioned in accordance with some clause. The individual air termination rods should be connected together at the roof level to ensure current division. Then radioactive air termination system shall not be allowed. Any other kind of air termination system like dissipation system, ESC system, CSC terminal system should not be. Rod means only rod. Whatever you use, idea is basically the radius of protection is the main contributor. Sometimes people claim that we can protect a bigger area. They will not tell the whole thing. Then basically, building remains unprotected then. So in order to avoid such kind of confusion and provide a serious, protection there, the normal rods are advised, and this is what National Building Code has written. And this is the right method. You put some rods there actually. And you can just now imagine if you are having a building and over the building you are putting some solar panels later on, it can, change the engineering of the lightning protection. You have to little bit redo it on the top of the building then, of course. Yeah, sometime, after building is constructed, people are giving this to telecom companies for putting a tower on the top. So if you look at the lighting protection design of this totally changes. And in that case, of course, you have to do this engineering again a little bit. Okay. So just this building, just a rod on the top of the building. And what is the radius of this? How much, or basically till what distance this rod will catch the light, or lightning will strike on this rod. So formula for this is also given in IEC. 10 multiplied by I raised to power 0.65. Very simple formula. Now, in level 1, we know that the current is 3 to 200 kiloamperes. So as I told you, it is the lower current which actually creates the issue. So for 3 kiloampere, just let's put this 3 kiloampere here in this formula. So what will be the radius? Radius will be 10 multiplied by 3 raised to power 0.65. So it comes 20.42 meters. Yeah. So sorry, it's a typing mistake here. It is 20 meters radius actually, roughly 20 meter radius, which is for level 1. it is associated with 3 kiloampere. If we calculate with 200 kiloampere, the same formula, it will be 313 meters. That means a rod can protect a 200 kiloampere lightning if it is striking within 313 meters. Yeah, one can definitely claim this. But what is the worst case scenario? Worst case scenario is here, 3 kiloampere, when it can take a lightning within 20 meter radius. So that is why with this formula, I given you one statement at the beginning, lightning decides its target actually within 20 meters. So same formula applies to the rod here basically. So within 20 meter, if the lightning is going to strike, then the possibility of strike on the rod will be quite high actually within 20 meter. It is not that it's going to attract the lightning from other buildings here, not possible. Within 20 meters, this is the case. If it is not there, then anything else will attract it on the building actually. Building lightning is going to fall somewhere. So in this case, you put the rods, and rods are the preferred points basically for the lightning to strike, because there are multiple actually, right? And they are calculated, the distance and position of these rods is calculated with the mathematical formulas, not by just marketing claims actually. So for level 2, you see 5 kiloampere, and 5 kiloampere, if you put this 5 kiloampere value in this formula, you will see a radius of 28.5. That is why we take 30 meter radius in level 2. And level 3, when we put 16, it's actually level 4. Again, it's one mistake here. 16 kiloampere, so it becomes 60 meters just by this simple formula. 16 raised to power 0.65. So in this case, you can see that the radiuses which were shown here actually in this slide to you. Yeah, in this slide, 20 meter, 30 meter, 45 meter, and 60 meter. They are coming based on some logic. It is not that we can just we are just claiming. There is a formula behind it, and this is based on these currents 3, 5, 10, and 16 kiloamperes. This is what I promise that I'll be telling you more about this. So even basically, in the rolling sphere method, if you take, let us say, bigger sphere here, this device, this particular object is anywhere protected here, But when you go for the smaller one, so it will touch this also. So that's what I was saying. So there is a possibility that the lightning actually will strike on this point also when we go for level 2 or level 1. The shorter is the radius of this. That means more number of rods are required, more conductors are required actually in that case. But as I told you, level of lightning pollution depends upon the risk. We cannot say that if the risk is mitigated by level 2, then still we will go with level 4. That will not be that useful. Okay, so here for high-rise buildings, basically buildings which are 60 meter or above, actually you can Shashank ji, basically somebody is taking the control of this these slides actually, and it's getting disturbed totally after that. Can you remove fellows from the presenter mode actually? That will be. Yeah, okay. So if the building is more than 60 meters height, then of course there's a requirement of having a mesh-like structure on the top of the building, 5 by 5 rated, and this structure or this meshing has to be done on the top 20% of the building. So this full structure acts like a lightning capturing system. Yeah, and also this also gives an angle to other objects which are there below, and this is applicable for the high-rise building and high mast, etc. So this is being followed in the buildings which are being constructed in various parts of the country, and it is important to take care of this important part, because why you just see that on the side also there are air termination system here. The reason I shown you in the second slide. lightning can strike from the sides also. So this is a protection against side flashes actually, which is required in all the structure which are 60 meter plus. So effects of lightning strike on the metal roofs, you can see this like a gas welding thing. It can create a puncture there. And lightning is a heavy current. When it flows through conductors, it will create a force, and due to this force there could be deformation or this kind of effect that you can see in the second picture here, where the ducts itself can come out of the walls. So it is quite possible in the lightning case, and that is why when we use the lightning protection components, these should be tested for high force, these should be tested for corrosion and humidity, and also high temperature. So these all tests are carried out, and these testing standards are 62561 for the components of the lightning protection. So ultimately, any structure you find, there are rods, and ultimately they are giving a kind of cover, virtual cover to the whole structure, so that lightning is striking preferably on the rods and not on the other part of the structure. And this is what you can see, that these are the arcs of the lightning of the rolling sphere, and these are touching these rods only, not anywhere else on the actual building. So whole building is protected. This is 3D design concept basically, which is done for the building. So now even for the solar structure, basically we put this kind of rod so that lightning doesn't strike on the panel, but it should strike on the top of this rod, and then you can see that lightning rod is connected to the structure, and which is finally grounded. So the connection of these rods with the structure is also done very tightly with the proven connectors there actually, which are rated for such high lightning current and the force created because of this. Second part is the down conductors. As I told you, we have to make a kind of cage of the building. That means basically you will see so many down conductors coming in from all the directions. So what should be the numbers of these down conductors, and what should be the distance between the two down conductors? If we put all of them together, whether they will really affect in a very efficient way or not. Then how these should be mounted or routed. Can these be close to the power lines or no? I think you can answer it very clearly now. Can these route through the cable ducts? Can building reinforcement be used as a down conductor? The saria that we use inside our pillars and all, can we use that steel or the saria as a down conductor? So is there any possibility of uncontrolled flashes? That means there could be very high potential which is there on the down conductor at a height which can create a surge, and what should be the size of the material? These are some questions basically which come into our mind while talking about the down conductor, the part of the cage which is coming from top to bottom actually. So answer is here, minimum 2 down conductors are mandatory in case of single air termination system. So any building which is having only one single air termination system, you should have at least 2. Yeah, and these 2 should run on the opposite side. Why on the opposite side? Because they will nullify the electromagnetic effect. Very, very important. Second is the use of building reinforcement as down conductor is permitted, provided you have conductivity from top to bottom. If the conductivity is ensured, and for that the overlapping of the steel, the steel structure, reinforced steel, the saria inside, the bonding wire, the kind of welding is to be done, all are defined in IC basically, how one should do it actually, so that the conductivity is maintained. And also considering the force, not only just the conductivity, basically the force that is impressed by the lightning while there is a strike on these conductors, that is also taken into account while designing all these things. For example, there are 11 bonding wires which are bonding roots which are required on the two overlapping steel structure, so that basically this never falls apart even during the lightning force. Minimum distance is shown in the next table. I will just show it to you in the slides which are coming next actually. And then the use of special cables It is also there. It is having dielectric strength. That means if your lightning is coming down from top to bottom, there are special cables also available now, which will not allow lightning to, cross these cables. It will not allow lightning to jump to the other power cables or so, which are coming close by. Those kind of cables are also available in the market now. Routing of the down conductors to electrical or other shafts is strictly not allowed. So this is some common points actually when we are talking about lightning. And then distance between the two. That's what I just told you, that I'll be showing you this. In level 1 of protection, the distance, typical distance between the two down conductors is 10 meters. Actually, this is a typical one. Sometimes you have, in the design, if there's a door that is coming in, if there's a window that is coming in while coming from top to bottom, then you have to adjust it. So there is a variation possibility of 33% in this. And then class of lighting protection 4, for example, the typical distance between the two down conductors will be 20. So if the perimeter of a particular building is, let us say, 100 meters, then in case of level 4 protection, so 5 down conductors only will be required in this case. In case of level 1 protection, 10 will be required, because you will divide this parameter by 10. And in case of level 4, you will divide it by 20. So less number of conductors will be required. As I told you, level 4 will be the least costlier one basically, and level 1 will be most costlier one in that, but most effective also, because we are talking about 99% surety here of the lightning capturing, and also basically possibility of occurrence of the lightning 3 to 200 kiloampere is also 99%. So this is what is telling about the conductors, and to tell a little bit about the flashes which can occur due to the lightning. See what happens, basically ground level is a zero level, but once you go up in this down conductor system, the voltage across the down conductor system will be higher. It will be highest on the top, and then it will become zero when it is there in the ground, in the down conductor system. It is because of the mutual inductance with other conductors basically. So this L here is not the conductance or the inductance of this particular conductor. It's a mutual inductance with the other associated conductors in the building. So since this voltage will be developed because of di by dt lightning, then of course this will go up, and there will be a point basically where this voltage will be good enough to create a spark here or create a flashover here, and this flashover can create some arcing in the building level itself. So in order to avoid that, there is a requirement of a separation distance, and this separation distance is also covered in IEC 62305 part 3. Actually, this is one of the important pillars, and in order to avoid that, you can use the special cables as I was explaining you earlier. So I will give you some photographs also basically of separation distance maintained or not maintained here. Basically in this case, if you see, this is the lightning conductor, and this is the power cable, very close to each other, and lightning will definitely create some association with the power cable here. Here in this case, you see there is these are the cables which are coming in, and on the right picture, this overlapping white or gray color vertical terminal is the lightning protection system, which is just going across the cables. Of course, all the lighting will go in the cables also in this case. So in such cases, basically we should definitely take care of the separation distance. Otherwise, very purpose of lightning protection or providing lightning protection may be lost. Yeah. So, and what should be the size of these down conductors? Basically, normally it should be 50 square mm, but 50 square mm is not required for carrying the lightning current. It's not the simple formula of, calculating the size of the conductor as we do for 50 hertz current. It's a you can say it's just for microsecond it's coming. So actually 16 square mm is sufficient, but why we keep it extra? Considering the force, it will not melt away, but considering the force that is generated. So if you are able to have that additional force by some other material across 16 square mm, so you can definitely go for a very highly insulated conductor, which is specially insulated conductor, which is there for even smaller diameter than 50 square mm. So it is possible. Actual requirement for carrying the current is only 16 square mm, as we do for the surge protection and all. Basically, maximum we go for 35 square mm maximum. It's not required like this. IC says 50 square mm for bare conductors actually, and this is required. So 50 square mm can be achieved by a strip, let us say 25 by 2. We do it 25/3 in India, which is quite good actually, because it's higher than this. Or a round conductor, let us say a dia of 8 mm square round conductor, 8 mm dia basically. 8 mm dia means radius of 4. So if you look at the area of this will be pi r square. So r square will be 4 into 4, 16 into pi. So this will be 50 square mm. So when we talk about a round conductor should be having rating of or dia of basically 8 mm there, if it is bare. If it is basically shielded, or it is basically protected by external insulation, then dia can be further reduced. No problem in that. So these are some conductors which I was showing you with the special shield outside, which doesn't allow lightning to go out. And I'm not supposed to tell more about this here. Some clamps actually which are rated for very high current, 200 kiloampere, tested for these clamps and all. These are the selection criteria for external lighting protection components. When we use these components for lighting protection, we have to see that these are tested for lightning currents, that force, and the aging of this, with salt mist and humidity tests, etc. There's list of tests which are avoided, which are mentioned in the IEC 62561 standards, and these are to be followed. So coming to the earthing part, actually, as Mr. Arora has yesterday taken it up quite nicely, so I can tell only about two things about the earthing here. One is type A earthing and type B earthing. Type A earthing is nothing but vertical earthing. Type B earthing is nothing but horizontal or ring earthing. For electronic equipment, it is always considered that we should have type B earthing, because we will have a ring equipotential bonding everywhere, and the chances of potential difference are very, very less. Don't go for digging too much less, because as Dr. Oda yesterday explained quite well, that is, magic is not in digging actually. Magic is in achieving what you want, and what you want is to be very clear. So really the low resistance you want, or it's a equipotential bonding. But one thing is clear, that whatever we do, we cannot have zero resistance. That everybody will agree with me. Yeah, actually. Yeah. So of course, earthing part I'm not covering today, because it was already done yesterday. Just to show some picture, that when we are having the deep driven rod there, basically this is the requirement, like 3 meter is one of the requirement. Like in Middle East, I think it is less. It's not always 3 meters, but it depends upon soil and application there. And in India also, basically we do the same, but we assume that if it is deeper, then it's bigger. But actually that is also one of the myths that we have, that was already created yesterday. So when we go for horizontal earthing, then in that case we have to go for double of the length here. Instead of here basically 2.5 meter inside the pit and 0.5 meter leaving up, basically 0.5 meter remains the same, but here as you see, the length is, instead of 0.5 meter, instead of 2.5 meter, we are having 5 meter length here, double of that actually. And the best is always to create this ring across the building, like it is shown here in the building itself on the right side, and this will minimize any ground loops also, and also it is safer for the people who to walk in there, in that area. Of course, this part was also taken up yesterday. When we are using earth as a carrier or as a conductor for the current, basically, then we are totally dependent upon the soil resistivity. If the soil resistivity is very high and there is a fault, so the current which is flowing through this earth, or the flowing through the network, will be reduced by the resistance of the earth, let's say. And in that case, the current may not be sufficient enough to trip the switchgear here, and this dangerous voltage will keep on appearing on the body of the equipment in case of a fault. So in order to give a very quick and a kind of like analogy with the ambulance, as was shown yesterday, basically. So we have to give a very quick path back to the source, as far as the short circuit path is concerned, or the fault current is concerned. So current always go to the source, and this is the source basically of this fault current, and fault current will go to this. Should not be confused with lightning at all. Lightning has some different phenomena. It's nothing to do with the source and this. It is a discharge phenomenon, discharge of a capacitor or discharge of a battery, actually. So here, earthing, good earthing, design the earthing so that it can take the current back safely, without creating any touch potential, safe or step potentials. Actually, should not melt away with the things, and also should not create any reference issues or heating issues there. All these designs are fantastic, but at the same time, for lightning, what we need is a equipotential bonding. Yeah. So coming to the equipment side now, actually in the last few minutes of the slides, I will just explain you about the equipment. Now basically you have already captured the lightning, down conducted the lightning and dissipated the lightning into earth. But do not forget that, I use one sentence that earth, what is the best earth? Nobody knows that. It cannot be reduced to, the earth resistance cannot be reduced to 0 ohm. It is not a superconductor. There will be some value of the earth resistance always, actually. So now in this case, when we are talking about the equipment will be exposed to some kind of current. As we know that lightning current cannot go totally into the earth because it is not 0 ohm. So some part of this will go here and there, and this here and there is nothing but basically, and every equipment is then exposed to some surges or some lightning, some part of this current. And you see that basically every equipment is having some withstand level, like 230 volt equipment, which is on the LV side actually. It is working on a 230 volt nominal voltage, and we say that it can work in plus minus 10%. Sometimes it can exceed that value. It can work from, let us say, 150 to 300 volt. It can withstand even 400 volt for some microseconds. It can withstand, 1 kV also for some microseconds. But when we go for higher voltage, we reduce the current. We reduce the time. So that means it is always I square T value which actually matters, or voltage, current, and the time value that matters actually. But at the same time, every equipment is having some withstand level, and that withstand level is the strength of this equipment, the insulation of this equipment. Now let us say if the surges are in the range of the withstand level of the equipment, as I can show you here basically on the sine wave. If these are in the green range, there will not be any damage to the equipment. This is a safe area. Nothing will happen to the equipment. If the surges go beyond this area, there could be some damages to the software. There could be some, physical damage to the equipment, and there could be some, damages which are beyond your reach. Also, there's corruption of the software and memory and things like that can happen because these surges are beyond the acceptable range of the equipment. And the catastrophic thing can happen when the lightning or any big thing comes, which is much beyond even this equipment degradation level. See, in case of degradation, basically this kind of slow poison. When lightning or when there are small surges, if these are not damaging the equipment in one go, these are actually degrading it slowly and slowly. It is making this green area smaller and smaller. And that is why sometime in a blue sky, if there is a damage of the equipment due to a small surge, it is because the equipment has already degraded actually. It's the aging effect, which happens in the semiconductors and everywhere. So it can happen in the blue sky, it can happen in even small fluctuation in the surges. So this green area keeps on depleting, I would say, like our ozone layer. So it keeps on depleting with every surge or every kind of lightning. Lightning may not be directly, or in one instant damaging them. Of course, if it falls on the building itself, then of course it is a big issue. But at the same time, if it is a distant effect only, just see that every monsoon your TVs and everything are getting some kind of degradation, even if they are not damaged. It is definitely going to happen. And if you see the quality of the picture of the new TV and the old TV, you can see the difference. Same model, everything same. So last one will be the catastrophic failure, where the lightning comes and immediately everything vanishes away. So this can happen in case of lightning. Of course, when every surge or this energy is beyond the acceptable range, then of course this can also happen very, very clearly. Now in the equipment side, actually, lightning, you have protected the building against lightning. You have done very good earthing. Let us say you are maintaining 1 ohm there. If you are maintaining 2 ohm, it is same for me. If you are maintaining 0.1 ohm, that is also almost same for me. If the lightning strikes, it's a constant, it is a current source, it's not a voltage source. Lightning will try to go to the earth. And while this current of 100 kiloampere tries to flow through 1 ohm of resistance, which is maintained by very good earthing system and also very good mesh system and whatever we use, 100 into 1 will be a voltage on due to Ohm's law, because V is equal to I into R. So that voltage 100 into 1 is 100 kV will be appearing across the earth point of all the. Now on the other side, basically your lines will still be at 230 volt, and since these lines are at 230 volts, there will be a potential difference, you see here, and due to this potential difference there will be a flow of current from high potential to low potential. In this case, basically current is flowing from high potential earth to the low potential lines, not from line to earth to lines actually. Even after maintaining 1 ohm, if it is 0.1 ohm, then it will be 10 kV. 10 kV is also good enough to create very good current here. So I would not say you can reduce this resistance to a very low zero value. So unless you can do that, earth will not create that kind of great effectivity here. Potential gradient for sure, yes, but at the same time everything is dangerous even at 0.1 ohm. So here the equipment will face very heavy current to flow through this, and this potential difference which is creating this heavy current will damage this equipment. That is the basic problem. Like in your substations also, you have relays, SCADA and all these systems which are becoming more and more electronic now, and your green zone of the equipment is depleting automatically by change of technology actually. Yeah. So of course, and we know the importance of these controllers like PLCs and all. If these are damaged, there could be accidents also. So in order to protect these kind of electronics from such kind of effects of lightning, of course, you need to do something. And what is required to be done here is, like basically I'll show you one more example, which many of the participants who have already attended my seminars, they have seen this, and I mentioned this also in this seminar about the tank fire. Just imagine this metal tank, basically, Faraday cage, and in Faraday cage you are connecting this tank to the ground, and you are maintaining a resistance of 1 ohm. Let us say lightning strikes on the tank. Lightning will strike on a structure which is metal structure. Nothing will happen inside. Nothing should happen inside. But what we do is we keep some control equipment also inside, which are like some sensors, and these sensors are giving their output to control rooms which are located far away, having different earths. There are floating roofs. Roofs are floating in these tanks, and these roofs are floating with the shunts actually. These shunts sometimes create gaps while moving for years. And when the lightning strikes, the lightning tries to flow through these gaps, and the flowing of the current through gap is nothing but a spark. In second case, basically when we are looking at the shell of this tank, and inside that there is a sensor which is taking reference of 24 volt, and the shell is risen to 100 kV because of this lightning strikes. Ohm's law, simple. 100 kV and 24 volt, there is a huge potential difference. And if there is a gaseous environment at that time, tank is not full, tank is half or somewhere below this zone, there would be a spark, and this spark can create explosion. This is what happens actually. So this is dangerous, and of course I will not tell you the story what happens after tank fires and all. It takes lives sometimes actually. It creates huge issues with the pollution. It creates dangers, and of course if it spreads, it creates other big issues. So whole current is not going to be dissipated in the ground. Only 50% of the current as per IC standards are going into the ground. It can go a little more also. For calculations, we are assuming that only 50% is dissipated in the ground. Balance is associated with your conductors, which are control lines, which are power lines, telecommunication lines, metal pipelines, etc., etc., etc. Whatever metal is there, every metal will carry this current now. Now, for sure, when these conductors which are going inside the building carry lightning current. So they carry lightning current inside the building, and they are connected to some or other equipment inside. So that way, basically, the equipment is exposed to these high lightning currents. If equipment is exposed to lightning currents, then of course there would be damages in the equipment. Now we have to protect this. So only thing what we have done so far is here in the earthing and the balance of the metal in the building. Basically, the division of the current is considered as 50%, 50%, not 100% going inside the building here. So here we have to define that how much current goes to the power line. So in power line, you know, for calculation, the conductance of the power lines is great. So the balance current, this balance of 50%, balance 50%. That means if the total current is 200 kiloampere, the 50% of that will be 100 kiloampere, that is going to be there in the ground, dissipated in the ground, and balance 100 kiloampere will be associated with different metals. But for the calculation sake, we consider for the power line 100 kiloampere current can go into the power line. This is just for calculation. Actual current will be 93, 94 kiloampere. The balance 5 to 7 kiloampere will go in the other metals actually, because the conductivity of different conductors is less. For example, area of cross section of power line is always more than telecommunication line. So of course the conductance will be quite great. Quite better actually in case of power line. So more current will be associated simply. In case of single phase and three phase also there will be different current, because in single phase you have 2 cables going, in three phase you have 4 cables going actually. The 4 cables are coming in parallel and 2 cables are coming in parallel. There will be different level of current. So accordingly, you know, IC has defined that what is the ratings of single phase systems or three phase system accordingly. You know. So we have to talk about this 50%, which is shown in the left side here now actually. So now very important part which is to be seen here is we have one earth system and we have metal conductors. All the conductors are metal, live or neutral, whatever, all are metal. We are connecting all the metal together. Can we connect live lines together with the earth lively? No, permanently. Can we connect them? If we don't connect them, basically, just imagine inside the equipment, there is a live line coming, which is one metal, and there is a, you know, body of the equipment or earth terminal somewhere, which is at a different potential. Say two metals, different potential, there could be arcing flow of current through the PCBs, through the conductors, through the switching, and it can create problem. So you have to create equipotential bonding. That means equipotential means equal potential. Equal potential means connected together, bonded together. So can we bond these live lines together with the earth? That is the question. You know. So this is something which we'd like to answer in the next slide now. Actually, the same slide which was shown earlier. Here I will like to show you that the building which is showing this red kind of conductors here. Actually, this is having equipment which is running on 230 volt. The principle remains same whether we are talking about high HV or LV side. Here I'm just taking example LV side. You now know that how this 100 kV is created because of this Ohm's law, and this creates a failure here of the equipment, and no direct connection is live line with the earth is possible, and that is where you have to protect these by a parallel path. You have to connect line and earth together. Not permanently, but only for that microsecond when the lightning is existing action. So for that, in normal case, you need a switch which is normally open. In case of lightning, the switch should turn on, and by turning on, it will create a bypass path. The current will anyway flow, whether the switch is there or not. So if a switch is not there, the current will flow through the equipment. If the switch is there, the current will flow through the switch. But switch is now rated for lightning current. It can withstand that current. It can discharge this current. And it is also creating a kind of microsecond short, very, very fast short within line and earth. And that means the line potential for that microsecond is same as that of earth potential. There is no potential difference, equipotential bonding. That means no current through the equipment, and all the current is flowing through this switch. And this switch is nothing but a SPD, surge potential device. This switch is rated for this green wave, which I told you earlier. It is known as 10 by 350 rated arrestor, lightning current arrestor, class 1 arrestor, earlier known as class B arrestors. If the switch is rated for 8 by 20 wave, which was the red wave, small wave I've shown you in the first slide. So then this switch is called over voltage protection device, surge protection device. So lightning current arrestor, over voltage protection device, 8 by 20 waves, type 2 arrestors or class 2 arrestors. Yep. So that is the differentiation between the type 1 and type 2 arrestors. Yeah. So live lines to be connected via SPDs to earth in order to ensure equipotential bonding. See, whatever you can't connect directly to the earth, connected via SPD. Simple formula. Nothing to get confused here. Yeah. And rating of the SPD 100 kiloomphere. That is the requirement basically from the power line side. And more is the distribution of current, less will be the current per conductor, and less will be the rating of the conductor actually. So going forward, basically these lines are to be connected together. And how will you see this scenario? When the lightning strikes, everything will be at the same potential when the lightning strikes, just like you are traveling in the aeroplane. A bird sitting on the line, every metal part will be at the same potential, including the live lines. So there will not be any potential difference, so no flow of current, so no damage to any equipment. So that is the principle. So any electronic device like PLCs, SCADA and all these things, basically you will be having these data lines or alarm systems, and then when you are having the surge protection devices connected across all, they bring all together to one potential. That means everything is at the same potential, no potential difference, zero current, equipment is protected inside. So this requirement of SPD is also mentioned in National Building Code very clearly. These are some extracts from the National Building Code. Yeah, and also I will skip the zone concept. Zone concept may be taken in some different platforms. Here basically you can see that the arrestors. Here is the type 1 plus 2 plus 3 arrestor, which is required at the entry level. Why at the entry level? Why not inside the equipment? Because lightning currents are flowing through it. So lightning currents are not supposed to be flowing inside the equipment. So keep it away from the main sensitive equipment. Maybe it is going in the main panel, which is having all study devices there actually. So this is rated for 10 by 350 wave, type 1 plus 2 plus 3 at the entry MDB, main distribution level. And after that, if the distance between the main distribution level and the sub distribution level is more than 5 meters, then only you go for type 2 arrestors. Otherwise, there is no need of even type 2 arrestors. Only one at the entry is sufficient enough. It can discharge a current. And the connection of the arrestor is done like this. Here, 3 lines are there and neutral. Basically, line and neutral, there are every line and neutral there will be arrestor. And neutral to earth, there will be another arrestor basically, which is connected. When the lightning strikes, let us say on the 200 kiloomphere shown on the right side on the top here, 50% of that is going down, and balance 50% will go to this neutral to earth arrestor. So that is 100 kiloomphere. So neutral to earth arrestor will be rated for 100 kiloomphere. Then it is divided in 4 conductors, 3 lines and 1 neutral. So each line will have 25 kiloomphere of current flowing. So that is why the arrestors which are connected between each line and neutral will have 25 kiloomphere rating. Wave shape 10 by 350 mandate. One more last point here basically, which we are going to mention here before I show you some picture and finally close. This is a building and this is a arrestor. This is connected. And as told you, arrestor creates equipotential bonding. It has to create equipotential bonding here. That means line and neutral and earth are connected. When line, neutral, earth are connected, that means line and neutral are also connected. Line and neutral is connected. That means when the lightning strikes, there will be a short circuit also during this time. For sure, there will be a short circuit. Now this short circuit is followed by lightning. In lightning terms, it is known as follow-on current. Follow-on current is nothing but the short circuit. The short circuit current will flow through this arrestor. The arrestor is not only carrying the lightning current, it is carrying the short circuit current also. Now the capacity of the short circuit current, rating of the short circuit current will be decided by your transformer there. Transformer will define that this is the short circuit current, and whatever is the rating of the short circuit current, you have to define the rating, same rating of the SPD also for that short circuit current, or maybe it will higher. It has to be a little higher than what your other devices can be withstand. That is also the requirement clearly seen from this slide. Now, when the short happens, actually, of course, the short circuit current will flow for some time. But for how long the short circuit current can be withstood by this arrestor? So what happens is, Arrestor will discharge the lighting. It will be switched on due to the lighting. In normal case, it is in the parallel condition. Load is on, and when the lightning strikes, it switches on. Very heavy current flows through this, and due to this heavy current, the fuse or the switchgear will trip, and this tripping will cause interruption in the in the power supply to the load. This is also not expected, even if the lightning is there, as I told you, 24/7. So this is not 24/7. So what is expected from the SPDs is not only to discharge the current, not only to carry the lightning current, carry means withstand the lightning current till the fuse blows, but it should also limit this current also. So first, the rating of this arrestor with the fuse is always mentioned by the manufacturer, that I can withstand this much of current provided such a fuse is provided, because every fuse will have different characteristics depending upon the short circuit current actually. So these characteristics are aligned with the arrestor. So arrestor manufacturer will always define in the data sheet that my arrestor needs a backup fuse, and this backup fuse maximum rating can be this much only. Above that, it is not safe to use the arrestor with that fuse. So backup fuse rating, very, very important. Just see the data sheets of this. And the new SPDs which are available now, they not only withstand the current, they limit this current also. They limit the current to a level which are not sufficient enough to trip any kind of fuses or switch gears in the back. So that means they will discharge the lightning, they will withstand very high short circuit current, but additionally they will limit this current also due to the input mechanism they have. They create a resistance to the short circuit current for some time, and this current is limited there due to this resistance, and this limitation will not cause any fuses to blow. So thus such kind of SPDs are reusable kind of SPDs, basically where you can get 24/7 availability of the power, and this is what is now available for last, I think, 10-15 years now. It's not something very new. It's available now. I was just telling you about the history and how it started with. So normally, you have to ask for what is the follow current limitation in case of SPD, what is the short circuit withstand capability in case of SPD, and how much voltage the SPD is bringing down, because your equipment can withstand only 1.5 kV. So in 1.5 kV, whether the arrestor is able to withstand or are able to bring the voltage down to 1.5 kV or not. So as I told you, this is the basic structure of the basic layout of the SPDs, how these are installed. This is more clear now here. So if your backup fuses are more than the rated fuses in the data sheet, then you have to use the additional fuses. But by using these additional fuses, you have to see that the voltage here across this whole circuit will also increase, because you have to use the longer cable length here. The cable length which is connecting the line to the arrestor should also be seen, because cable length means inductance, and inductance means LDI/dt voltage. So this is the voltage that will go inside the equipment also, and this voltage has to be limited to less than 1.5 kV. So any addition of the components or addition of the cable lengths here will cause the damages here actually. The effectivity of the arrestors will reduce, and that is how basically EVN has to be very careful while installing these arrestors, as per the guidelines of the manufacturers. So I'll show you some diagrams here. Basically, this is a fire panel. The controls of the fire panels are protected by these arrestors. All the IOs are protected here. This is for the power line. You can see that for power line, these are the arrestors which are installed in the mains panel itself, can carry the lightning currents. In the control valves, controllers, basically field instruments, these are kind of arrestors which are used. Yeah, for different lines, different terminals, different connections, you will find different type of arrestors. And so everything ultimately comes to one potential, and that is the key of the lightning protection. So gentlemen, that is all from my side actually now, and we are left with 15 minutes of questions and answers. And before going for question and answer, maybe allow me to show you one slide, one or two slides. Basically, normally I show it in all my seminars actually. but it will be interesting for you to know, because most of the fellows are missing their holidays during this time. So let me take you to this place, which is Kullu Manali, actually. From my home state, I belong to Dharamshala, and this is from actually Kullu Manali. And this, you can see the airport of Bhuntar, which is Kullu Manali airport. The photograph is not taken from the aircraft; it is taken from the hilltop, and this hilltop is to be driven, or you can do the trekking also. It is 30 kilometers by drive. Takes 3 hours because you can't exceed that speed of 10 kilometer per hour over there. You can see this. This is me, and this is the road. Or otherwise, you can track there. Basically, very good scenic area actually. Very nice area. This is the area, and this area is known as Bijli Mahadev. Actually, you can see on the YouTube also today after this session that how how strange this place is. So this is a temple of Bijli Mahadev. Lightning strikes there every 7 to 10 years, and lightning actually kills, or I should not use the word kills, it destructures this particular shivling inside. This is made up of stone and collected with butter. When lightning strikes, the villagers around that area, they come, they celebrate this event. They say that Lord Shiva has protected them, and they bring white butter from their homes, recollect all the shivling, and the whole, there's a festival there in that area during this time. Fantastic, lot of energy and very scenic area. My personal recommendation to all of you is must go there. Don't go to just Manali as a town. Basically, there's nothing there. Go to such places which are fantastic and scenic, and you will find full of life. Now here, one tower was installed, and after this tower was installed, it was not Lord Shiva who was taking the lightning always. It was sometimes going through the tower also, and it was going inside the equipment also. So some damages in the equipment were seen, and also the protection of these equipment were required. So the point here is basically it is not that basically if one rod is sufficient or so. Lightning decides it on target, as I told you. It is very chanchal in nature. It is so mischievous in nature actually. So we have to take these signals. Just excuse me for a while. Just 1 minute. Yeah, sorry. So so we have to take the signals here actually. Very uncertain kind of event that happens when the lightning strikes, and we have to definitely take care of this. And I wish you all very safe days, safe stays, and also safe buildings, safe designs. And lighting protection is a responsibility of all the engineers. Of course, many of you are already contributing that, because I can see some fellows who are dealing in earthing there. They are also present there. Very nice work, I would say. Some fellows who are already dealing in surge protection, they are also present today. Very nice. Basically, all of you are contributing in a good cause. Spread your knowledge, not only about the product, but basically tell in general also to all. This is our aim, and we have started with the ELP Alliance also. Before taking the question, let me tell you more about this. ELP Alliance is open for all. Is a platform where you can share knowledge, you can gain knowledge, you can contribute in protecting the farmers of the country. You can contribute in getting the schools educated on lightning. You can contribute in creating courses for lightning in industries or in schools, in universities. Yeah, and of course you can contribute in a way that ultimately by the age of 60, 65, you feel satisfied that we have protected these many lives. So this is the first alliance that we have started actually, and thanks for joining this. Many of you have already joined us. I was very happy to have Dr. Arora, Mr. Murthy into this, and this is, it's a great honor. And thanks for all your contribution. We are going to be very active very soon. We are having 100+ guys there actually into this, and there are some international guys also who are willing to contribute in that. Already applied for this. ELPalliance.com. Please visit and please join there. And it is a neutral organization, nothing to do with Dehn, nothing to do with any other manufacturer. It is neutral, and those who are the manufacturers of lightning protection system, earthing protection system, my personal request to them is to please join in. So that's all from my side, and I'm very open for the questions now. Maybe the organizer can switch on the mics actually, if it is possible, or otherwise, you can write these questions on the chat, and I'll be very happy to answer these. You can ask these questions here also, vikas.almadi@dehn.in, and you can join ELP at this link, which I am. Sorry, this is just ignore this. Actually, the spellings are wrong. Okay, so some questions. Thanks for asking the questions, sir. I'll take one by one. Just let me open. So, is there any software for lightning protection study? Yes, there is a software basically where you can do the risk assessment. You can design the lightning protection system. I'm not supposed to give you the brands here. Basically, you can connect us for the software. There are softwares available for lightning protection studies. So with the it's from Gaurav again. Gaurav, with the PLC system installed in power plant, we observe that there is a hunting in value whenever there is lightning. As I told you, sir, there could be such events happen because the softwares and the references can change during this time, and uh, it's the electromagnetic effect also. There could not be any physical damage, but there could be such kind of effects of this, and this really proves that. So for sure, you have to mitigate this while using the protection for the PLCs. Mr. KK, this year many deaths in villages took place due to lightning. Suggestions to our villagers to save themselves. Yes, sir. Very right questions, and this was mentioned during my presentation also. Of course, first thing is the awareness. Who will create the awareness? Not only government, but the experts will create the awareness, and that's why I told about the ELP Alliance. Please join this. Please join us together. We are conducting Nukkad Nataks actually for the farmers, giving them the books basically which are written in their language to understand the lightning, some precautions during the lightning, and also these are some small things. But after that, for protection, industry has to come forward, creating some shelters, having some lightning warning systems so that they can take the action well in time. All these things are required in our country, but somebody has to start. We have to, I'm not using the word wake up, but we have to, create this theme or this team in the government, in the industry, in the local bodies, so that these kind of ecosystem can be created, lives can be saved. That is one thing. First is awareness, second the technology is also available, simple technology, not much of the things, but at least simple technology, and this can be done for sure. We have got our earthing checked, and still there is some issue every time. I think this is to do with Dr. Arora, and okay. Devang Tel ji, basically you are saying that which one system is better, ESC, CTS or conventional? Sir, it is not about better or not better. Basically, there is only one system that is being approved by IEC, and IEC talks about Franklin rod. And Franklin rod, you say, is conventional system or modern system. I am not going into that debate also. But at the same time, basically, this is the system which is the most reliable one and which is recognized by IEC. Of course, I have given you some examples, some calculations of the current and radiuses also. There are claims by all for the better performance of that, but there are counterclaims also basically. So a best system which is proven and finds a very respectable place in the Standards is a conventional lightning protection system, Franklin rod system, but not one rod. You have to design it properly actually, right? And there is no magic in any rod. Whatever you put inside, put capacitors, put inductors, call it, early stimulus, advance, or whatever nice name you want to give, but ultimately everything acts like a normal rod. So one rod which is costing some 500 rupees, or one rod which is coming up with nice paint and everything costing 1 lakh rupees, it is up to us which one we have to choose. But everything acts like a simple rod only. So it is rod that works actually. Yes, so good. Thank you very much. Thanks everyone for joining this session. And I think we are quite well on time, 5 o'clock. Thanks for, nice questions also. Sorry for the interruption in between. I don't know why it happened. It's not in my control. But sometimes it happens actually. We have to forget about this. And don't forget to go to this Bijli Mahadev temple. Actually, you will definitely like it. And my best regards to you. Stay safe. Thank you very much, Sigrid. Thank you very much, CBIP, and all the seniors there who are joining today. I'm very thankful to you. A lot of gratitude and a lot of respect. Thank you.
Thank you so much, sir. Good afternoon, everyone. We have come to the end of this important event. It is my duty to propose the vote of thanks. The need of the subject has been well appreciated during the deliberations, and I'm sure the discussions will go a long way for the benefit of the utilities, manufacturers, and the professionals all over the nation. We are indebted to Shri Nihar Raj, Chairman SIGRE, National Study Committee B3 on Substations, and Vice President and Head O&M Adani Transmission Limited for agreeing to our request for delivering the keynote address during opening session of the tutorial. We are also thankful to Dr. Rajesh Arora, BTech, ME, and PhD in Grounding System Design Manager, Delhi Transco Limited, and Dr. Vikas Almadi, CEO and Director, Dehn India, for accepting our request. And we all know they have made valuable presentations in this program. We are also thankful to our sponsors, Messrs. Dehn India and Messrs. Intertech, for their support in organizing this important national tutorial. We are also grateful to all the participants and distinguished guests. Well, I think we are right on time. So I want to assure you that we recognize and appreciate directly or indirectly for the success of this event. I thank one and all for making this tutorial a success. At the last, I would again like to repeat to all of you to kindly uh, consider membership of CBIP and SIGRE India. As you all are aware, CBIP has quite a list of publications and guidelines, which has till now also benefited a lot of organizations, PSUs, and I'm sure it will be beneficial to all of you. Thank you all for joining us. We'll meet again in future programs also. Thank you, sir. Thank you, Vikas, sir.
Thank you very much. Thank you, everyone. Bye.
Thank you, participants. Over.